When your MCP tool fails, will your code crash with an obscure error or handle it gracefully? You'll see exactly how to wrap tool calls in proper error handling, using FastMCP's built-in ToolError to catch failures cleanly while still accessing the result data when things succeed. From FastMCP exceptions, import ToolError. Async with client. Try. Result equals await client, call tool, potentially failing tool, param, value. Print, tool succeeded, result data. Accept tool error as E. Print F tool failed, E. This demonstrates the exception handling pattern for robust tool execution in distributed systems. The code shows how FastMCP implements defensive programming by wrapping tool calls in try-catch blocks, creating a clear boundary between successful operations and error states. What makes this distinctive is the framework's dual approach. It provides both automatic exception raising for convenience and manual error checking for granular control. The pattern works by treating tool execution as a fallible operation with two possible outcomes. FastMCP's call tool method either returns a structured result object or raises a tool error, forcing developers to explicitly handle both success and failure paths. This design principle enforces error awareness while maintaining clean code flow, as the framework manages the underlying protocol details and state transitions. This approach matters because it solves the common problem of silent failures in RPC systems. By making error states explicit, it prevents undefined behavior when tools fail, which is critical for production systems. The trade-off is slightly more verbose code, but the benefit is predictable behavior and easier debugging, especially valuable when integrating with AI systems or other automated clients that expect deterministic responses. Let's break it down line by line. From FastMCP exceptions, import ToolError. This imports ToolError, the exception class for handling tool failures in FastMCP. It enables explicit error catching for tool-specific failures, separating them from generic exceptions. Async with client. Async context manager pattern ensures the FastMCP client connection is properly initialized and cleaned up even if the tool call fails. Eliminates resource leaks by guaranteeing connection teardown when the block exits. Try. This initiates a try-except block, the standard Python pattern for error handling. It isolates the tool call so failures don't crash the program, allowing controlled recovery through the accept clause. This is defensive programming. Assume external calls can fail. Result equals await client, call tool, potentially failing tool, param, value. This invokes the AI tool named potentially failing tool with a parameter dictionary, using FastMCP's async client interface. The await handles the asynchronous execution, allowing other operations to run while waiting for the tool's response. This is the standard pattern for calling FastMCP tools from Python code. Print tool succeeded, result data. This outputs the successful tool response, accessing the data attribute where FastMCP stores the actual result payload. The pattern assumes tools return structured objects with a data field containing the meaningful output, separating it from metadata like status codes or timestamps. Accept ToolError as E. This catches ToolError exceptions, the dedicated error type for FastMCP tool failures. It isolates tool-specific errors from generic exceptions, enabling precise error handling without disrupting the broader control flow. This pattern ensures failed tool calls don't crash the application, just log and continue. Print F tool failed, E. This error handling prints the ToolError exception message, giving immediate visibility into why the tool failed. Critical for debugging, it surfaces the exact error without crashing the application. Follows the pattern of graceful failure handling in async operations. FastMCP error handling. The exception-based approach with ToolError provides clean separation between success and failure paths, while raise on error equals false gives granular control when manual inspection is needed. Catching ToolError at the client level ensures consistent error handling across all tool calls. But remember that raw MCP protocol access bypasses automatic deserialization. This pattern makes error states explicit rather than hidden in return values, improving debugging and recovery.
The error that speaks clearly is the only error that can be heard.